Thanks so much, Tab. I wish I could be there in Gillingham today, but I am sitting in Anchorage instead, which is also not a bad place to be. Um, so I'm going to talk a bit today about the connection between glaciers and the Bristol Bay landscape and salmon. Um, and we're going to also zoom out and think about glaciers in Alaska and their connection with fisheries and salmon as a whole. And because it's Earth Day, I'm going to also have some Earth Day soapboxes as well. So I'm going to share a little bit more about who I am. So hello, everybody. My name is Aurora. Um, I am an Alaska kid. I grew up in Fairbanks, and my parents both worked at the University of Alaska Fairbanks. And so I grew up around people that were doing science in Alaska. And I think this really impacted um, how I wanted to contribute to community. I saw science as a way of loving Alaska. And I remember being very young and going to talks about climate change and changes in Alaska at UAF. And this is the reason that I do what I do now, which is that I study ice and have studied ice in all different parts of the Earth, from Greenland to Antarctica, and my favorite places in Alaska. Um, and I've been doing this for over a decade now, which is kind of wild to say. Um, and let's see, can you see? Yeah, see that. So currently, what I'm doing is I'm finishing up a PhD, actually down in San Diego, but then I work remotely in Anchorage. And as part of the PhD, I actually work mostly in Greenland, and I think a lot about how the fact that we're having more glacial melt, how that's changing our ocean ecosystems. But there's a lot of connections between Greenland and Alaska and the changes that we're seeing in both places. So something that I think a lot about is comparing Alaska and Greenland, and we'll do a little bit of that in the talk today. And then the other thing that I spend a lot of time thinking about and trying to work on is um, figuring out how scientists can do better science that is grounded in relationship and reciprocity with Arctic communities. Um, the history of science in Alaska has been, intertwined with colonization and control of resources. And I also think science can be a beautiful way to love a place, to understand a place better. But we have to do that in collaboration with people that live there. And I'm going to be talking about glaciers, near Dillingham today. And this is, you're all back. This is your backyard. So I don't think myself an expert in this place at all, and I want to learn. And so part of the impetus for doing this lunch and learn is that I get all of you in a room together, and you can share what you know about this place with me. So I very much want to emphasize that this is a dialogue and a two-way street. But I will share sort of the lens that I have of studying ice and how that has allowed me to see Alaska in certain ways. Okay, I think that's all that I wanted to say here. So when you study ice, and you're, sitting on a plane from Seattle to Anchorage, and somebody asks you what you do, and you say, "Oh, I study ice and glaciers." The way people often respond is they say, "Wow, that must be really sad," or they say, "Oh, well, you must not have a job for long," and kind of, chuckle. Um, and I get it. It is sad. It's not, we're thinking about immense changes to landscapes and to places that we love. So there is a lot of sadness, but I get kind of annoyed because there's so much more to glaciers than just melting. And that's what we're going to talk about today. And two of the points that I want to drive home are that glaciers are one part of a mosaic of an ecosystem. And so if glaciers are changing, a whole ecosystem is changing. It pulls on the thread of this entire ecosystem. And we'll talk about what some of those threads are. And then the other point, I think when we get sad about these things, I think there is definitely real grief. But leaving it at sadness sort of means that we abdicate our responsibility. If we see glaciers as just these objects that are melting and they don't influence anything in our day-to-day lives, but it's just sad that they're melting, it means that we don't really have to do anything about it, or it means that maybe we don't think we can do anything about it. So I think when we understand glaciers as a part of this larger holistic system, we actually become more responsible to taking action and figuring out how we can conserve our ecosystems that support us. And because it's Earth Day, I really feel like I have to, talk about that. um, okay, so a couple years ago, I had the immense privilege of getting to kayak through Wood Tick Chick, the series of lakes near Dillingham, with Chandler and Lily, who are maybe in the room. I can't quite see who's all in the room. Hi. And Casey as well. And our friend Ben, and then Tab and Devin joined us at the end as well, and we're awesome support people. Um, and I had never been to Southwest Alaska, and kind of classic, urban Fairbanks Anchorage kid coming to Southwest Alaska. I was just like totally floored. But the first thing I noticed as we were, kayaking through Lake Nurka, um, was that there were glaciers. And I, have stared at maps of glaciers in Alaska my entire life and have, been studying this professionally for over a decade. And nobody ever told me there were glaciers in Southwest Alaska. And so I just was really shocked by that. And, having this lens of glaciers working with an ecosystem, the first thing I wanted to know was like, okay, well, how are the glaciers interfacing with the ecosystem in Bristol Bay? And it's not a coincidence that you have the, world's most abundant wild salmon fishery in a place where glaciers used to be much bigger and where glaciers still are. And so this really kicked off my curiosity to trying to understand this place. And I tried to read everything I could about what had been written about the glaciers of this region. I couldn't shut up about it on the trip. Sorry, Chandler, in case you have. But that's what I'm going to be presenting today is the results of that research. And I also, again, I really want everyone's perspective in the room as I nerd out about this with you all together. So I just want to give you a heads up about where we're going. We're going to look at sort of the glacial history of the Wood Tick Chick area, and then think about also present day and then the future of these glaciers. And then we're going to zoom out to thinking about glaciers around Alaska and how those impact fisheries. And I'm going to constantly have a lens of sort of how glacier change is influencing salmon. So that's where we're going and what we're up to today. Before we dive into the glaciers near Dillingham over here, I just wanted to give a brief overview of glaciers in Alaska. These are just some stats and figures that I think are good to know and put us in context. So glaciers take up about 5% of the total land area of Alaska, which is quite a lot. And for the past decades, we've been losing about 83 gigatons per year of ice. 83 gigatons is a lot of ice, and it's hard to imagine, so I'm going to show you what a gigaton actually is. But another way to think about that is between 2010 and 2020, Alaska glaciers alone, so just Alaska glaciers, contributed to about 2.3 millimeters of global sea level rise. So that's the entire global ocean, having 2.3 millimeters more all around the whole globe because of melt from Alaska glaciers. Just to give you a sense of what a gigaton is, it's a lot of ice. This is a visualization that shows Central Park in New York. And if you put 1 gigaton of ice in Central Park, it would create this block of ice that is about 300 feet tall. So this is 1 gigaton. And every year, glaciers in Alaska are losing 83 gigatons. So that just gives you some perspective of like how much ice and what immense landscape change is occurring right now. I'll also note that a lot of the data that I'm showing you is from NASA or the National Science Foundation. And as you guys are well aware, in terms of the cuts with NOAA that are happening, NASA is also receiving similar cuts. National Science Foundation is receiving similar cuts. All of this data is public, and we can do this science because of that federal funding. So I just really want everyone to appreciate that that's what we're looking at. But looking back at Alaska, I had looked at maps like this for many years, and I had always failed to notice this little area near Dillingham that has glaciers. And so we'll zoom in. This is an area that you're all familiar with, and that I'm, falling in love with. And the thing that really sticks out are the lakes, right? And even when you look back at the history of people doing science and sort of geologic expeditions to the region in the late 1800s, everyone comments on the lakes. And these lakes are exceedingly deep, up to 900 feet deep. And that is because they were carved by these glaciers. And sort of the two most, glaciery glaciers that still exist in this region are the Chickahominy Glacier. Hopefully I'm saying that right. Somebody please correct me if not. And then there's sort of several small cirque glaciers on Mount Wasky too in this region as well. And when trying to look at sort of the current science that's been done on these glaciers, a lot of it revolves around describing the glacial history. And that's because people were interested in the lakes, people were interested in the lakes as salmon habitat. And so it led Western scientists to naturally think about, okay, well, how did these lakes come to be? How did the glaciers carve these lakes? And so we're going to talk a little bit about that and sort of put this into some geologic context. So these lakes were carved by the glaciers about 20,000 years ago during what is called the last glacial maximum. And that is when sort of the ice sheets across North America were the largest that they last were. And so that was about here in geologic time. This is showing 800,000 years of global temperatures as well as global carbon dioxide measurements. We know this information from ice cores, from sediment cores, from corals, from cores from corals in the ocean. And all of that data points to this picture of what global temperatures were and what global carbon dioxide levels were. But there are periods where we have these big ice sheets that grow, and these are called glacial periods, and that's when global temperatures were colder. And then you also have interglacial periods where global temperatures were warmer. And these fluctuations in temperatures had to do with small changes to the orbit of the Earth and the tilt of the Earth's axes that changed the amount of radiation coming into the globe. And this is happening over tens of thousands of years, hundreds of thousands of years. So the time scale is huge. We're going into deep time, and we have to have this perspective shift of time that is hard to do when we are humans that live, if we're lucky, 200 years. So the lakes were carved 20,000 years ago, which is actually not that far back in geologic time. And this was when this ice cap, the Ackland ice cap, had about this much ice and this extent. And it was sort of this little island of ice when there were these larger ice sheets covering all of North America. And I had never, again, this was something, I had a lot of classes about this, had studied these large ice sheets, and had never learned about this little ice island that was occurring in Southwest Alaska. And the process of this ice growing when it was cold during a glacial period, and then retracting when it was warm as we entered an interglacial period, created these lakes that became perfect salmon habitat. And you can see that carbon dioxide and global temperatures track almost exactly. And I looked up today what our global carbon dioxide levels are, and they are 430 ppm. This is to scale. So we are, the highest carbon dioxide levels that we've been in all of human history, at least, going back 800,000 years ago. I just want to give you a sense of sort of these ice sheets in this last glacial period, 20,000 years ago. So you can see we're at 20,000 years ago. And this is a computer model that uses historic data and our knowledge of how the climate system and ice sheets work together to look at landscape change. And it's this kind of information where we run climate models in the past to understand what the climate of the future might hold. I'm going to let that play to the end. You can see, and I'm going to play it one more time, and I'm going to point out some things that I want you to notice. One thing you can notice is where Dillingham is in this sort of Southwest Alaska ice island of the Ackland ice cap here. And then the other thing that's interesting to notice is how sea level changes as the ice sheets recede. And these ice sheets receding, changing sea level is what has really created the coastline all throughout Alaska, all throughout North America, and given Bristol Bay the characteristics that it has. The other thing is, if we're thinking about salmon, salmon were co-evolving as these ice sheets were changing. And so there's been actually a lot of interesting work that's shown that as the ice sheets receded, you had salmon migrating north and then colonizing freshly deglaciated coasts along northern Canada and Alaska. And so I think that's also really interesting to think about sort of salmon and ice sheets on these really long time scales. Okay. And then that was a really zoomed out view. I want to think about just what, looking at sort of single glaciers like Wood Tikchik. So this is actually the Alps, but you can kind of see there's a similar pattern of like lakes and mountains, similar to Wood Tikchik. And this is a much more modern computer model. This was just a couple years ago that this was run. And what I want to show here is, if this will run, I'm actually going to start it here, um, is that ice doesn't just melt away uniformly, but it has these periods of advancing and retreating and advancing and retreating. And this carving action is what creates the lakes like we see in Wood Tikchik. And you get these moraines and you get these connected features all in the landscape because the glaciers are advancing and retreating and advancing and retreating. And it's not just an ice cube melting away. When you look at it like this is, we're in 40,000 years ago, so this is a lot of time that we're traversing, but glaciers really seem like this alive creature when you are able to look from this perspective. And you can see how these lakes might have been carved as glaciers advanced forward and then retreated. And they're depositing sediments as they carve these lakes. And even though this is the Alps, we can, think that something very similar happened in the Ackland ice cap in Southwest Alaska as well. And then you see sea level change here. We're at 8,000 years ago. Just going to let it run to present day. Okay. I can move forward, maybe. Okay, so that gives you a sense of how we got this landscape. And really this diversity of landscape with really deep lakes connected by rivers is like the perfect salmon spawning ground. And without this little ice island of the Ackland ice cap 20,000 years ago, we would not have this variety of landscapes that have allowed salmon to thrive here. And so I can't emphasize enough this connection. And this is probably something, I assume that a lot of you have probably heard this and thought about the geologic history of the region. But I just think it's important context as we think about this place. So now we can think about sort of the present and the future of these glaciers. And there's really only been one study that's tried to think about how these glaciers are changing in present time, so in the last decades, and then project that forward to thinking about the future for these glaciers. They did this by using satellite imagery as well as old aerial photography. And then they would draw outlines around the glaciers from these photos and then just would compare them from the time periods. So we have 2009 is in the orange. This was from satellite imagery. And then I think the dark blue was from the 1950s. And so you can see this change from the 1950s to 2009. I think the green is from the 80s of Chickamanuck Glacier shrinking over those decades. So this gives you a real sense of the landscape changes that are occurring right here in Bristol Bay. And then they calculated, what the total glaciarized area for this region is and did it for those 3 time periods. And then drew a straight line through it and said, okay, well, if this trend continues, we will only have 10 square kilometers of glaciers by 2100, by the end of the century in this region. This is, when you only have this limited data, this is one way to think about the future, but it's actually quite unsatisfying, right? We have much more sophisticated ways to think about the future of glaciers. But nobody's actually applied those sophisticated ways, those computer models, to these glaciers. And so that's, something I'm like, oh, if I had unlimited free time, it'd be fun to actually do that. But I wanted to give you a sense of how we use future computer models to think about the future of ice. And there are some folks at the University of Alaska Fairbanks, Andy Ashwanden, that does this for the whole Greenland ice sheet. And so I just wanted to show you what this looks like when we think about the future of the Greenland ice sheet. This starts in 2008, and then it runs to 2300. And this uses our best understanding of how ice and the climate work, and then compares it to our past understanding where we have actual data of what these ice sheets were doing. And this is in the scenario of, it's called RCP8, which is our, most possible carbon dioxide scenario. That is the path that we are currently on when we think about our future. But you'll notice that even when we're on the worst case scenario of global heating and carbon dioxide, by 2300, there is still ice in Greenland. That's not to downplay, the huge landscape change that is happening and the impacts and the sea level rise caused from this changes. But it's just to say that not all ice will completely vanish. That will take many, many more hundreds of years for that to happen. Um, and I think it also, says something about these glaciers too, that if they can stay high enough and cold enough, it might not totally be gone by 2100. You might have this little patch of ice that stays right at the coldest, tops of these mountains by 2100. But we'd have to do some more sophisticated modeling to really say for sure. Um, so we've talked about ice loss, but the question that I've always sat with is, what does it mean that we're losing this ice? What are the impacts to downstream ecosystems because we're losing all of this ice? And so to answer that question, we're going to look to Southeast Alaska and look around the Gulf of Alaska because that's where a lot of this work has been done. And this poster really changed my life. This came out in about 2014, I think, and was really when Western scientists in Alaska were starting to see glaciers as part of this mosaic of a landscape rather than just melting ice cubes. And there are all these different connections for why glaciers matter to our ecosystems. And so we'll talk about a few. The two biggest things are that glaciers impact overall stream flow, both the amount and the timing of water throughout the season. And then the water that comes from glaciers is distinct from other kinds of stream runoff. And so we'll talk about both of those things. So in terms of overall stream flow, I want to think about sort of decades and we think about a glacier retreating. So let's say we have climate warming. That means our glaciers retreating, we're losing ice. And initially, as you're losing ice, you're actually going to have more water from that glacier. And then your ice is going to become so much smaller that then you have less water. And this is in terms of decades. And this is called sort of the runoff curve of glaciers. And this kind of information is really important, especially if you're thinking about like a hydro, if you want to put in a hydroelectric project and you have a glaciarized watershed, you need to know which part of the curve you're on. Can you expect there to be more water in the coming decades because you're in this sort of active retreat phase? Or has your glacier already crested this curve and you're actually going to get less water from your glaciarized basins? And you need to account for that if you're designing your hydroelectric project. So that's in terms of decades, how glaciers change stream flow. But then also seasonally, glaciers really impact stream flow because they act as this, bank of ice that can release water all year round, or sorry, not all year round, but all through the summer, and can do so at greater quantities. So if you have a non-glacial watershed, maybe you have some snow, you initially get some snow melt, but then that kind of tapers off throughout the summer. And then you also have a lot more variability because it responds more to rain events and precipitation. Whereas if you have a glaciarized watershed, you get a lot more melt initially, just because you have a lot more ice that you can melt. And then that stays high throughout the summer. And it's also smoother because the glaciers kind of buffer out these, pulses of precipitation as you get rain. And so you can imagine that if you have a stream that is controlled by a glacier, it's going to have really different characteristics than a stream that isn't. And this also means that the things that live in that stream, like juvenile salmon, are going to need to respond to those changes. So that's the amount and timing of water, but then what's actually in the water is different when it comes from glaciers versus when it doesn't. And I think one of the best ways to show that is just the difference between a creek that is coming from a glacier and a creek that isn't. This is near Juneau, in the Montana Creek area, and this is where these two creeks come together. And it's just so obvious to see that you have so much more suspended sediments. That's why it's teal and turquoise here, because there's really fine grained sediments in this glacier water versus the non-glacier water. And this is because of the erosional work of glaciers. They can grind sediment into really fine flour, and that stays suspended in the water. And so I imagine, and you probably all know this better than I do, but the lakes of Wood-Tikchik, the bottoms must just be lined with glacial sediment like this. That's really, really fine. Um, and this mechanical grinding also has chemical repercussions. It makes sort of nutrients more available in the water column. And when you change some of the nutrients that are available, then you can change what can live in those streams. So glaciers are impacting the river food webs. And so you can think about as we go from, more glacier basins to less glacier basins, you're then also changing the river food web, and then you're changing what salmon can eat in those rivers. One of the things that's been interesting about this work is they really highlight that salmon need a variety. So it's not about having a glacial stream or a not glacial stream that they do better in one or the other. They survive and thrive in both environments, but what works the best is if they have a variety and go in between these different environments. And so as we lose our glaciers, we're losing this variety of stream types, basically. And then this is some great work that's been done recently that shows, the overall landscape change from retreating glaciers changes the characteristics of streams. And then they also connected that to sort of what species will benefit, what species lose out. And so as you lose a glacier, you're actually creating more habitat potentially for salmon to spawn in. And so there could be some colonization of salmon spawning in rivers that were previously, under ice. And there's sort of winners and losers in this process. And there's different times in this phase of retreat where you have salmon sort of winning and losing. So for instance, like the turbidity, which comes from glacial streams, is great for coho and chinook when you have still glaciers that are creating, enough sediment in the water to make it turbid because it allows them to hide from prey. But as you lose the glacier and you lose that fine sediment, the water becomes clearer, as we saw in that picture. And so that means that that's worse for the juvenile salmon because they can't hide from their predators. So this is, it's a really complex picture of the changes, and it's hard to say, just one story when we think to the future of salmon and glaciers. So, taking that of what we've learned from Southeast Alaska and applying that to these glaciers, these are really such small parts of their individual watersheds. So their watersheds encompass a lot more area than just the glacier. So they're probably playing a very small part in buffering the amount and timing of water that's coming in, and as well as changing kind of some of the sediment composition and the nutrients in the river. And so a lot of these things that we just talked about for other Southeast Alaska glaciers, happened to this region at, 20,000 years ago as those glaciers were retreating. But that's, nobody's really studied that here. I mean, there's one paper I found that looked at the watersheds that were dominated by snowmelt versus rain events in Wood-Tikchik. And there are differences between the snowmelt watersheds and the rain-dominated watersheds. And so you can imagine that glaciers help keep snow around longer. So there's some work that's been done there, but it's not a huge factor. But so I just wanted to connect kind of what we're learning about other glaciers across Alaska to what's going on here. And unfortunately, these are so small that they're probably not having that much of an impact on the overall watershed anymore. Going, salmon spend a lot of their life in the ocean. And so mostly I've been talking about, river and lake systems and how that relates to salmon. But we can also talk about the ocean and how glaciers are connected to the ocean on a large scale and what that might mean for fisheries. So that's what I'm going to talk about now. And we're going to zoom out to the whole Gulf of Alaska. And when we look at the Gulf of Alaska, we have this pretty big current called the Alaska Coastal Current that traces from, northern British Columbia all the way up the Panhandle and around, and then kind of comes through the Aleutians here. There's actually really interesting dynamics as the current splits around the oceans. But this current, the Alaska Coastal Current, its movement is driven by the fact that you have lots of runoff, freshwater runoff from glaciers all along the coast. And you have fresh water from these glaciers entering a salty ocean. And the density difference between these two waters creates the ability for this water to move. The density differences push currents around the globe, and that's what's driving the Alaska Coastal Current. So, on a very big scale, runoff from glaciers, melting from glaciers, helps move the Alaska Coastal Current. Now we can zoom in a little bit more to one region, and it's not just about the fact that this runoff is fresh. Again, this runoff also has sediment in it, and so this is coming off the Copper River Delta. So this is what's draining a lot of the glaciers in the Wrangels and the McCarthy area. And you can see this, these turquoise areas here are all sediment that are coming from the river and largely coming from glaciers. And it's been shown that the sediment is actually quite high in iron. And the Gulf of Alaska ecosystem, in order for phytoplankton to thrive, so the base of the marine food web, they need an input of iron. So they're what's called iron limited. And when they get this input of iron from glacial rivers all along the coast of Alaska, it actually helps cause the spring bloom of phytoplankton, which then supports the entire marine food web. The other thing, the way that glaciers are connected, is you also see this huge dust cloud. So this is dust not in the water, this is dust in the atmosphere. And as we have glaciers receding, we are opening up areas of just really fine-grained dust that has no plants to keep it in place. And so when you have wind events, it's moving all of that glacial dust into the atmosphere, into the Gulf of Alaska. And so it's also been shown that that input of dust in the atmosphere that then falls into the ocean is supporting phytoplankton blooms and the entire marine food web. And then we're going to zoom in again to just thinking about one glacier. And this is one of my favorite things in the whole world. This is what I specifically studied, which is glaciers as upwelling mechanisms. So upwelling is when you have deep ocean waters that are brought to the surface. And this can happen in coastal regions where you have different current dynamics, but this also happens at the fronts of glaciers. And the reason this happens is because you have glacial meltwater that percolates throughout the ice and it runs under the ice like a big river. And that river then comes out at the bottom of the ocean here where the glacier is in the ocean. And because this is fresh water entering dense salty ocean, the fresh water rises. And you can kind of think of like a smokestack or a big plume that's rising. As it's doing that, it's entraining the ocean around it, and it's bringing up really nutrient-rich, deep ocean water to the surface, where then it's available to the light and available to phytoplankton. And so this is a big driver in sort of the entire marine food web to have this upwelling mechanism at the fronts of glaciers. So this only happens where glaciers are in contact, directly in contact with the ocean. So you can think of some of the big glaciers in Alaska. If you've ever been to Kenai Fjords National Park, you have glaciers that are terminating in the ocean, and this is what's happening there. And you can imagine that as we are losing ice and glaciers are retreating, and they lose their contact with the ocean, then you lose this mechanism of bringing nutrients from the deep ocean to the surface of the ocean. And so this is something that we're actively studying in Greenland and that people are actively studying throughout Alaska. And Nicole Abib is on the call, and she's a scientist in Kenai Fjords that is studying this process in Kenai Fjords. But because, the salmon in Bristol Bay, also go to the Gulf of Alaska, they are influenced by these processes of the entire marine food web that glaciers are a part of. I want to show, since I have a little bit of time, I want time for questions, but I'm just going to take the last 5 minutes to show what these glacier plumes look like. And this is from our work in Greenland. And I also want to point out just the scale difference of glaciers in Greenland versus Alaska. Like, we think we have big glaciers here in Alaska. The ones in Greenland are much, much bigger. And so this gives you a sense of scale. And this shows the plume that's rising in front of this big glacier coming to the surface, and it's so vigorous that it's actually pushing ice that's fallen into the ocean. It's pushing that ice out of the way, and it creates this kind of pool. The other thing you'll notice is, here, I'll go back, if I can go back. Oh, maybe. Is there's all these birds here. These, I think, largely kittiwakes, maybe. Um, and that's because they are taking advantage of all of the nutrients that have come up. And also the fresh water entering the salty ocean can sometimes shock zooplankton, so little shrimp that are in the ocean. And the zooplankton don't like going from very salty environment to a very fresh, cold environment, and basically they just shock and they float to the surface, and then it's buffet time for the birds. So again, this shows like how glaciers are creating this really vibrant ecosystem. And then this is how we study those things in Greenland. I just wanted to give a sense of the scale here. Um, and we try to measure at the front of these glaciers what's going on with these plumes and how they are interacting with the ecosystem. And this is my advisor, who is amazing. So we're dropping a probe into the ocean that measures temperature and salinity so we can try to find where that fresh water is in the salty ocean. And we're trying to do it in this little pocket in between all of this ice. And this is still the helicopter right there. That just gives you a sense of yeah, scale and how we're doing this in Greenland. Um, and we're trying to work with local communities in Greenland to look at how glacier change is impacting fisheries in Greenland. There's Greenlandic halibut. Well, they don't have salmon in Greenland. They have Greenlandic halibut and other fish. And there's a lot of similarities between sort of how communities do subsistence hunting and fishing in Greenland. This is a seal hunter that we talked with while we were out there. This is a baby halibut. And we're really trying to understand glaciers here in this holistic sense, and how they're relating to communities here. So I just wanted to give a plug for that. Um, and then finally, what I wanted to lastly leave you with is the sense that Western scientists, we're actually catching up to what people that experience these places sort of already know in their bones and have known for generations of how these landscapes are connected and how glaciers are connected to so many different things. And so my friend Annika Ord, who lives in Juneau, she did some work where she compared sort of what Western scientists are talking about when they talk about glaciers, and then she interviewed elders and knowledge holders, harvesters, subsistence and commercial harvesters, and local scientists um, about what connections they see with glaciers. And so if we look at just what sort of Western science has and kind of the like published literature, you see a dominance of sort of glaciers connecting to temperature and water level, mixing and upwelling, sediment. These are all the things that I just talked to you about. There's starting to get more connections with salmon, and we're thinking about water resources and tourism. And so we are trying to branch out from just thinking about ice and water. But I want to compare this to when she did interviews with elders and knowledge holders, harvesters. There's so many more connections, and you can see the complexity here. And so our experience of these places, is just as valid as the Western science that we can do. But the Western science also helps deepen our understanding. But I really want to stress that we're catching up to what we know about these places, and I'm catching up to what you all know about Wood Chick Chick and the glaciers here. And so that's again my plug to please talk to me about your experience with these glaciers and what you think is going on with their connections to salmon. So with that, these are my takeaways. So I hope I gave you a geologic time perspective shift, and sort of putting today's global temperatures and glacial retreat into context of what has happened in the past. And I hope you can see how glaciers helped create the perfect salmon habitat in Bristol Bay and what they mean for the environment today. And then, throughout Alaska, presently, glaciers are a really important part of our marine and river ecosystems, but we still have a lot to learn. And the last thing is, really the future of glaciers depends on actions that we take today. The future of our marine ecosystems depends on actions that we take today. And I really do think that we uh, act and take action when we love something. And I see sort of science as a way of expressing that love in Alaska. And so I hope this allowed you to love this place a little bit better. So I'll stop there. And yeah, would really love questions or comments and stories. So yeah, please, yeah, take it away.
Thank you, Aurora. Any questions? About online?
Yeah. I'm really curious about the mechanism you described of glacier melt coming out underneath the saltwater lens and bringing up, we hear about, nutrient upwellings, lots of places, which are generally places where there's a lot of life. And I never really thought about it. Like what you're describing is at the bottom of the ocean is like this compost pile that's been developing over millions of years, and there's lots of good stuff down there. I know that part I found particularly interesting. I read also that the ice cover in the Bering Sea, for instance, when the sun returns to the northern latitudes, the sunlight produces an algae bloom underneath the ice, which is attracts a lot of critters. And part of that same mechanism. And this isn't really a question. I'm just I don't know. Every once in a while, you got to think about this stuff, But thank you for this.
Yeah, I'm glad you appreciated the glacier upwelling. I think it's um the least known and most interesting thing about glaciers is about how they influence our marine ecosystems. And the way you described it as a compost pile at the bottom of the ocean that's exactly how I think of it too. And yeah, glaciers are amazing that they actually make this compost pile then available. Um, and nobody, as far as I know, nobody's really quantified, like if you think about all the glaciers in the Gulf of Alaska that are doing that process, like how much of that upwelling is occurring, like how much does that matter to the whole system? Some people have done that in Greenland, and it really does. It has a big impact on the regional ocean. So that's something. Not that we need to quantify everything, but I think to get a sense of like how important is that mechanism. That's something I'm curious to do.
Well, thank you for this. Thank you.
Any other questions? I had a question about future research, just in general. It seems like, with the ability to do satellite imagery, that's a big focus. But do you see any opportunity for like using drones in small scale or like local rural places?
Totally. Yeah. People are doing a lot of that. Where they can make really like you can take a drone, fly it over a glacier, take a bunch of pictures, and then stitch all those pictures together, and then you get a really high resolution. It's called digital elevation model, but model of that glacier. Um, People are doing that a lot in the Alps, sort of those smaller glaciers, and then also in the Himalayas as well. Um, so yeah, I think like that's definitely an application that people are doing. Would be cool to fly one over for the mountains here. Yeah.
And
What's a day in a life of a glaciologist like in Greenland?
Yeah, I mean, there's kind of two modes. There's my day in the life here, which is in Anchorage, which is sitting in front of my computer, looking at data and writing. But then there's the much more glamorous days, which are in Greenland. These days, I work primarily on boats. So we're on, smaller research vessels in these fjords in Greenland, trying to get as close to the ice as we can. And then we're working around the clock to make as many measurements as we can. And because we're trying to understand the connection to ecosystems, we also have like fisheries biologists on board. biogeochemists. So it's this really like interdisciplinary group of people, which is really special. And so, somebody will do a net so that we see what we pull up and what fish species are there and what fish larvae are there. And then we'll have to count that, and we'll be up to our elbows in krill and fish guts and slimy things. And then I'll send a bunch of instruments over the side of the boat to measure the temperature and the salinity of the water. And then we just keep doing that on repeat. And because we're far north and because it's the summertime, we pretty much do that 24 hours a day, trying to get as much data as we can.
You talked about the glacier melt here impacting salmon habitat in a small amount. Are there other places where it's impacting the habitat in a large amount?
Yeah. So the places where the glaciers are melting the fastest in Alaska, a lot of that's in Southeast Alaska and around Juneau. Um, so that's primarily where a lot of these studies have been done. So Aaron Hood at University of Alaska Southeast is the one that's sort of been leading that work. Yeah, and they're seeing like really, really big changes to the stream flow conditions, because you have glaciers that are receding really fast. I mean, if you go to Juneau and you see Mendenhall Glacier, just thinking about that in my lifetime, that's changed so much. But we haven't really looked. People have also been looking in Kachemak Bay area as well. So the glaciers across from Homer, there's been a lot of work done there. But beyond those two sites, beyond kind of Juneau and Kachemak Bay, we can only really speculate based on what we know in those two sites, what's happening in the rest of Alaska. So I think there's a lot of work more to be done there. Oh, and the other thing I wanted to mention that I forgot is that not only is it sort of nutrients and sediment coming from glaciers, but there's been some more work on like contaminants, so persistent organic pollutants, as well as mercury that are higher in glacier water. And this is because the glaciers kind of act like a sponge, like they're sort of sitting high in the mountains, collecting, mercury that's maybe falling out of the atmosphere and persistent organic pollutants, bad things, industrial waste things that kind of get stored in these glaciers like a sponge. And as we're getting more glacial melt, those are now melting out more. And so that's another aspect of this too, is that you have more contaminants in glacier melt often. But again, that's only really been looked at like in Juneau. And so we have to speculate for the rest of Alaska what that might mean. Oh, I see Jessica online with her hand up. Hi, Jessica.
Hi, Guiana Aurora. Oh no, my screen kind of froze. The one thing that really stuck out for me was how glaciers and the runoff makes the little current that goes to the Aleutians. Is there any simulation or like what is the future of that once all the glaciers are like if they all melted out, will that current still be there to push water up the peninsula?
Yeah, totally. I'm not as much of an expert in this. That's a great question. I think we're already starting to see some observed changes to that current with basically we're having more fresh water that's being input right now because the glaciers are like really melting. And then you can imagine that then once those glaciers are all receded, we're going to have less fresh water. And so that will have impacts on that current. I don't think it's not going to totally stop or go away. But it does have changes, locally for where water might go. I think there's larger currents that are happening in the regional ocean that would sort of continue that general trend and have it go through the Aleutians. But yeah, it's definitely something people are actively working on. I know at UAF at least, that's like one thing they're studying, that current specifically. Thanks for the great question.
Any others?
Aurora, thank you so much for this. How do we give you information about anything about glaciers in Bristol Bay? I mean, how do we keep the dialogue going with you? What do you want? How do we get in touch with you? That kind of thing.
Yeah, any way. Yeah, email is probably the best way. So I have Tab has my email. I think my email is on the slide there. Um, and I also, I want to come visit you and Tab and come hang out. So maybe if I can make it to Dillingham, we could do some sort of like another lunch and learn pizza session or something and have more people talking than just me. So I can learn from all of you. I think all of this was just my curiosity of like what I had heard about Bristol Bay. And so maybe all of you are like, oh, we already know this. This is old news. But also if you have other questions about glaciers and your home, I'd love to, figure out how we can answer those questions too.
Awesome. Thank you, Aurora. Appreciate you taking the time. And I think we'll stop it there. Thank you so much.